Hello and welcome to a new video. In the video today we will talk about one of the design document, which is a control narrative. If we look at any engineering company, they will produce sets of design document. Each one of those documents is addressing one subject or a couple of subjects or one group of people. So if we could talk about the control system, it includes a hardware and a software, and there is a set of drawings and requirement for the control system to be able to design the system, and there is also for programming the system. So now we will look at what we need to control system programming. Now let's go into a real examples. And this is a PNID. In this PNID we have two pumps. Each one is 100%, so you have two pumps, each is 100%. One is working and one is standby. So you don't need to make any more description except a small note in the PNID saying one is working and one is a standby. Now, assuming you need to start the standby automatically if the pressure in the line goes below a certain value, you may also include one note in the PNID. If you wanted the standby, which has been started on a low pressure, stops on low flow, that means now you have a little bit more description you want to explain to the control programmer. So now you can see now you don't have much notes, space in the notes to do all of this. Furthermore, if you need to include some logic or algorithm which can detect the line breakage or line blocking, then now you can't have a space enough in the PNID or to do all of these calculation and things. So you need a separate document which explain all those stuff. Another example, if you have a tank and this tank has a variable density fluid in it and you want to measure the level, you can measure by different methods. One of them is the pressure. Now assume you have a foam or something on top of the fluid. You may say something from top would not be very reliable. I need to measure, let's say, from the side, the pressure from the side. So now, and because of the variable density, you can't rely on one pressure. So you need to measure the pressure at two nozzles with a specific known distance between the nozzles. You use the difference between the two pressures to calculate the density. Then you use the bottom, let's say 1, to measure the actual level based on the new density, calculated density. If you are afraid that one of those nozzles will be plugged by, let's say, the slurry or whatever in the tank, you have another set. So you have set 1 and set 2. Set 1 is pressure A and B, set 2 C and D. A and B will give you one measurement of level. C and D will give you another level. Now you use one of them as your tank level. You have a selector switch. The operator will select one of them as the tank level, and this new tank level, new tag, will be used for generating the alarms and everything. So this is your tank level, not this one or this one. But assuming you have a problem with one of the nozzles, that means this reading is not reliable anymore. So the selector switch will go to the second one. But how the system will know that this is not reliable? So maybe you say if the measured density is more than 5 or measure than 2 or measure more than, let's say, 1.6, that means the calculation is wrong. I have a problem with the one of those nozzles. If you said if one of this nozzle measure, let's say, the pressure below certain value or more than certain values, that means this nozzle is blocked and I'm not going to use the whole set, or I can mix and match between them. So now who will tell the programmer what to do? You will tell him what you expect him to do, but not how he will do it. But this is my expectation. This is a calculation which is I need you to do, and you put it in the control narrative. And so another example here, if we have A and B and C fluids, you are mixing them. based on functions, or based on equations, or based on a table. So you measure A and B, and then you go into the table and then figure out what is the required flow rate of the third component C, and this becomes your remote set point for your FIC here. However, if it is, this is not a simple ratio control. It's, let's say, I have a big table, 2 or 3 pages, or 1 page, or small table, or based on a recipe, based on a product selection, based on raw materials, quality, and all of this you can do it on the control narrative. So now we explained in real example what why we need a specific document to tell the programmer what to do, okay, and what our expectations. So it is a document which is developed by INC discipline, and specifically made for the control system programmer, and it's include all the control behaviors in various scenarios, also as a startup, normal operation, shutdown, control details, equations, calculation tables, and so on. Now, one of the other thing is that sometimes if you are a big company working in a big company, you may have a specific document which explains the HMI, what your lines, colors for different fluids, your, let's say, valves colors, what is the messages, how to display the message, and so on. But if you have a small company, you may not have all these things. Or also, if you have a big company, but this is a small skid, which is, you don't need him to use the HMI description, which is maybe 200 pages document. You know that he has only 2 or 3 valves and 1 pump. So you don't give him all this information. You give him the specific thing which is you need him to have on his screen as a color. So you may have some notes. This note related to the control system, related to the operation, related to the one of the things which is you want him to do. Last thing is that this document, we will use it to test our PLC or the DCS or our control system. So in the factory acceptance test, we use this document and we will highlight each line, each specific line, each paragraph, each table that we have tested this line and we found it okay. It's been programmed the way we wanted. But, and always there is but, the document is not an operation manual. This is not made for the operator or the panel operator. You may made another one for the operator, which is made by the process discipline, not by the INC, or you can do it if it's a small package, you can do it yourself. But I would recommend that you have a specific document for the operation manual. Now, the operation manual may have a specific stuff which is not in the control system. For example, if you have a specific way of draining the tank, draining the pump, if you have your system controlling, let's say, a recipe, and the control system found that one of the valves is stuck, he will stop and then he will give the operator a message, I have a problem. Now, how he will fix this problem, it is in the operation manual, not in the control narrative. The second thing, you don't specify to the programmer how to program his system. This is generic document meaning something for anyone to program his PLC, if it is brand A or B or C, or your DCS. So this is your expectation, what you want your system to do. Now, how to start this document? You started by looking at your PNID, and if you have a process description, the process description also will tell you what is the process guys want from the system. If only if the operation manual exists, then maybe you can rely on it, but normally the operation manual is developed at the late stage of the project, so you may not find this document. So you will start with your PNID. Now, what is the format of the control narrative? Each company has a different format, different way of explaining things, but this is a general idea. This is, again, a general idea, what you should include in your control narrative. In the beginning, you may start with an introduction. You may give the control engineer who's programming the PLC a little bit picture of what is the project, what is the purpose of the document, some stuff which is you want him to be aware of. Okay, now assume you have, let's say, train 1 and train 2, or pump 1 and pump 2, and pump 2 will not be installed now. So you need to give him some information about the stages of the project. Second, you will give him the codes and standard if there is one applicable to this control system. Then you need to give him a reference drawing. Now the reference drawing, you will give him all the list of the drawing which is you specified or talk about within the document. So you can include it in the control narrative, but normally you don't include it. The reason is each PNID by itself has its own life cycle. So if you, let's say, take revision 1 and make your control narrative, who said that the process engineer will not update the revision 1 to be revision 5? So now your control system is based on revision 1, and you included the PNID of revision 1 in your control narrative, and you will never know that the PNID has been updated. So there is discrepancies between the document. So I don't like to include the drawing in my control narrative. I just give them a reference to it. So he should go and bring the latest or the current PNID. But when you specify the document, sometimes you specify the revision which is used. I personally like to have the revisions also stated, so I give him the PNID 1, 2, 3, 4, revision 5. So he knows exactly which revision I'm working from. And the second thing now is your narrative. Now, what is your narrative? You can start it with a note again to the programmer. You may tell him again that in stage 1 I have the pump X and pump Y will not be installed, but you have to program it in the system, and to avoid a non-necessary alarm, and the operator cannot select the pump which is not installed. So I need you to put a temporary switch will disable all the pump Y graphics or control or whatever, and then this should be, let's say, on the screen or in the system, hidden in the system. So you go back in the system and toggle this switch on and off and so on. So you give him some notes. Now if you have, let's say, 5 pumps or 6 pumps, you will explain each one individually. But how about if you have, let's say, 10, 15 pumps? So your document now will be very, very big and unnecessary. So you may specify 1 pump as a typical. So when the PLC programmer or the DCS programmer will create subroutine or a method or a typical thing which is he do first, and then we test this unit and then copy and paste this unit or this program or little subroutine or whatever you call it based on the system, and then you repeat it in each one of those pumps or valves. And then you go into the narrative. How you start the narrative itself, you can start per train. So you can train 1 and then you explain it, train 2, train 3. Or you can take PNID 1, 2, 3. Or maybe you have a 2, 3 PNID only, then you will go only by equipment. So you find that there is no point in specifying the PNID, and you have only 3 PNIDs, and each one has 1 pump or 1 tank. So there is no confusion. You just to specify per pump, per tank, and so on. So per equipment. Here is one example. So in this document, you say PNID 1, and then you list all the stuff underneath, or as a table you take in pump 1 and you start explaining pump 1 control narrative, what you want in the pump 1 to do, pump 3, and so on. If you have, let's say, typically you say pump 1 and then you say go in typical P1 and use it. So and 7 you go in something else, but pump 2 you explain it because it's one of a kind. You don't have to create a typical for it and then you go there and come back again. So it based again what's easier for you, what's easier for the programmer and for the guy who read and use this documents later on. Now assume you have train 1 and 2 and 3 and they are identical. Do you think you can is better to have one for each train, or you have one for train 1 and you will tell him for train 2 you only change the tags based on a specific thing? And this comes back to the planning of your tags. Some people, let's say for train 1 they put a predecessor digit 1 and train 2 it become 2. So it's easy, very easy, because the same tag is repeated in train 1 and 2 and 3. So in the document it's be easy. Now another way of doing it, let's say in this document they are not aligned. So you say pump 1 P1 2 3 4, and then so this is train 1, this is the tag of train 2, this is tag of train 3, and then you continue suction pressure PI 1 2 3 4, and this is the corresponding tag in train 2, this is the corresponding tag in train 3. So now you, instead of making 3 document or 3 section each for each train, you can have one way of these things. And again, this is you can have hundreds of ways. There is no right, there is no wrong. It is how you make your document, make it clear and easy for the programmer and easy for the people who will use the document later on. So this is to summarize and put a small notes for you to maybe use. The first thing is try to use an abbreviation and definitions. Now the abbreviations may be helpful for the guys who using the document later on. So PLC is always referring to PLC, Programmable Logic Controller, DCS, blah blah blah. But also you can define when you say client, site contractor. What do you mean by site contractor or client? So you may say in the control narrative, the interface between the control system and the weighing system is by the site contractor. You will provide him with this data and you stay 1, 2, 3, 4. So you specify who is the site contractor, who is the client, so we know exactly what you are talking about. This is not only the definition, but also again, you can find hundreds of things you can put it in these definitions. Other thing is, let's say you define what you mean by the word shall. Shall meaning a must include feature. Now you say the system shall display this message. This means he must include this message. But if you say may, that means it's an option. So you can say when the alarm happens or whatever, the control system may display the following message or the following message. So now you give him 2 options or 2 things or 1 option and he can do it or not because you said may. So we said in the definition, may is an optional. Now the second item is try to use always a plain language. That means easy to understand. Words which can be understand have different meanings or 2 or 3 meanings. Don't use it. Be very clear and precise in your description. This is just a control narrative for the programmer. It is not more than that. So don't make it more than that. Now, the obvious, we're talking about, let's say, PNID control. So you don't include the PNID control because it's everybody knows PNID control. If your programmer doesn't know PNID control, that means we have a bigger problem now. So the obvious stuff we agree in the beginning of the documents will say logic PNID will not be included. Any PNID loop will not explain it in the control narrative. We're wasting our time, wasting everybody's time, and so on. So you find this obvious stuff, don't include it. Now, don't repeat information. What do you mean by repeating information or the instruction? Each control function is displayed in one paragraph or one section. Don't go back to the same function and give another information about it in a different section. So if it is exactly the same function, it should show in one place. Now this is one thing, but also let's say you have a set point. So if you said if the suction pressure reach below X number, let's say 50 psi or kPa. Now the problem is, where do you get this value from? You get it from the PNID. That's true, but who said that the 50 kPa will be on the next PNID? So you don't include this, but rather you said if the suction pressure is below the alarm point or the value stated in this document, do so and so. So don't repeat the let's say the set points and things which it shows on the PNID or in a document, another document, because each document will be updated by itself, and whoever will update the PNID will not update your control narrative. Now, and there will be discrepancies between the two documents if you keep repeating those kind of stuff. Be consistent, meaning if you look at, let's say, PNID and you start from left to right, top to bottom, always the same method. If you start with a pump suction pressure, then the delivery, do the same. So that's way when you write something, it's easy to catch if you forget something, and also it's easy for the programmer to know what's wrong with the document. If something wrong with the document, he say, oh, you forget to do this, because normally you do this and this, and in this place you didn't do the same, so we may have some problem here. So be consistent in your work. Now the most important item, which is the last one, is what is the purpose of the document. Now if we agree that this document is for the PLC or the DCS or a control system programmer, this is what we doing. So don't go beyond this thing, right? And don't try to explain things which is irrelevant to the this guy, right? And then also, this is not a test document, so you don't specify how to test the PLC or the DCS. The testing is another document. The methods of testing or the way of testing is another document. But this document is used as one of the tools. Like you take the PNID and you go to the control system and you look at the graphics he did. Is it matching the PNID or not? So the same thing about the control narrative or the cause and effect. You take it and you do the FAT and you look at the scenarios which is explained in the startup, shutdown, normal operation, low and high or something, and what the control system should do, and then what your PLC or DCS or control system is doing. So by this we concluded our video today. So thank you, and see you in the next video in the maybe another design document.